Picture yourself sitting at a really high-end sushi counter.
Oh, yeah, the best kind of dining experience.
Right. So the lighting is low. The chef is working with this, quiet, totally practiced rhythm right in front of you. And you are about to order.
The anticipation is the best part.
It really is. So you look down at the menu and you select two premium delicacies. And they sit right next to each other on the tasting flight.
Probably priced pretty similarly, too, I'd imagine.
Exactly. Priced similarly, presented with the exact same culinary reverence. You order unagi, which is freshwater eel, and you order uni, which is sea urchin.
Two absolute classics.
Yeah, and on that handmade ceramic plate, they look like absolute peers. I mean, they both come from the water, they both carry this incredible luxury status, and they represent the absolute pinnacle of global dining.
You really do.
But what the menu doesn't tell you is that you are about to eat two creatures that exist in entirely different biological, ethical, and, frankly, ecological universes.
Completely different worlds.
Yeah. One is this migrating, almost mythical vertebrate. Its birth remains one of the great mysteries of the natural world. And the other is the reproductive organ of a spiny invertebrate, capable of devouring entire underwater forests until literally nothing is left.
It sounds like science fiction when you put it that way.
It really does. So today, we are taking a massive stack of fascinating sources. We've got stuff ranging from marine biology and taxonomy to archaeological history and global culinary
A
economics.
huge variety of material.
Yeah, and we're embarking on a mission to answer one profound question with all of this. Can we farm the ocean the way we farm a field?
I mean, it is a question that completely defines the future of how humanity will eat. Because when you sit down at that sushi counter, you are participating in a system that is currently undergoing a massive, invisible revolution.
Invisible to most of us, anyway.
Right. For tens of thousands of years, we were hunters and gatherers of the sea. But now, we are attempting to be its engineers.
Okay, let's unpack this, because I want to start by completely unblurring this catch-all term we use all the time, seafood.
Oh, yeah, that word hides so much.
It does, because that word implies that everything in the ocean is basically the same kind of crop, right? We talk about it like we talk about produce in a grocery store.
Like it's all just tomatoes and cucumbers.
Exactly.
Yeah.
But if we actually look at the tree of life, what are we eating when we eat an eel versus a sea urchin? Like, are they even remotely related?
The biological distance between these two animals is just staggering. So let's begin with the eel.
Okay.
When we talk about culinary eel, especially in the context of high-end sushi or traditional Japanese cuisine, we are usually talking about the Japanese eel. Scientifically, that's known as Anguilla japonica. And the very first baseline to establish here is that an eel is a true fish.
Wait, I need to stop you there, because I think a lot of people, myself included at one point, look at an eel and think, well, that is a water snake.
Oh, completely. It's a very common misconception.
Right, because it has no obvious scales. It moves in this super serpentine way, and it just doesn't look like a trout or a salmon or what we picture when we hear the word fish.
And that visual deception is entirely due to millions of years of highly specific evolution. I mean, they are vertebrates, meaning they have a backbone, and they are ray-finned teleost fishes belonging to the order Anguilliformes.
Anguilliforms. Okay.
Yeah. This is an ancient lineage of bony fishes that dates back to the early Cretaceous period. So we're talking roughly 120 million years ago.
Wow, that's old.
Very old. And their ancestors were not snakes that returned to the water. Their ancestors were typical fish-shaped fishes.
Wait, really? So they used to look like normal fish?
They did, but over eons, their bodies became increasingly elongated and flexible. They lost their pelvic fins entirely, and their dorsal and anal fins, well, they fused into one continuous ribbon all along their body.
So they essentially stripped away all the external hardware of a normal fish just to become more streamlined.
Exactly. They possess gills, they have a highly specialized muscular structure for that undulating movement you mentioned, and they are built for navigating incredibly complex, tight habitats.
Like squeezing through rocks and mud.
Right. And they also developed a remarkably thick layer of mucus on their skin, which is why they appear scaleless.
Ah, so they do have scales.
They actually do. They have tiny scales embedded deep in their skin. But that mucus layer protects them from abrasions when they are sliding through jagged river rocks or really dense vegetation.
And that's a lot of sense.
Yeah, and it even allows them to survive briefly out of water.
Wait, they can survive out of water?
Just briefly, yeah. By keeping their skin moist enough, they can actually absorb oxygen directly through it. So they are, in every biological and anatomical sense, highly evolved fish.
Okay, so that's the eel, a highly evolved, slimy fish. And then we have uni, which is definitely not a fish.
Not even close.
Uh.
So uni is just the Japanese culinary term for the edible part of a sea urchin.
Right.
And for our purposes today, looking at the sources, we can focus on the purple sea urchin, Strongylocentrotus purpuratus. That one is a major player in both marine ecosystems and human consumption. But yeah, uni is not a fish.
It's a bug.
No, it is not a shellfish either, meaning it isn't a crustacean like a crab, nor is it a mollusk like an oyster. And importantly, it is not roe or eggs in the strict biological sense.
Wait, really? Because you will see it called that on almost every English menu. They always say sea urchin roe.
I know, it's everywhere, but roe implies you are eating just the unfertilized eggs, right? Like caviar.
Yeah, that's what I always assumed I was eating. So what actually is it?
Uni is the gonad.
Oh, wow.
Yeah, the actual reproductive tissue of the sea urchin responsible for producing either sperm or eggs. You are eating the organ itself.
That is wild to think about. I am literally eating the reproductive organ of a spiny underwater ball.
Pretty much.
So where does a sea urchin sit on the tree of life then? It's not a fish and it's not a bug like a crab. What is it?
What's fascinating here is that sea urchins are echinoderms.
Echinoderms.
Yeah, they are part of an incredibly ancient lineage that includes sea stars, brittle stars, sea cucumbers, and sand dollars.
Okay, I can see the resemblance to a sand dollar.
Right. The wider echinoderm group has roots reaching deep into the Cambrian period, over 500 million years ago.
Oh, so they are way older than the eels.
Way older.
Hmm.
But here is the massive evolutionary twist. Echinoderms are what biologists call deuterostomes.
Okay, you're going to have to translate deuterostome for me. I have no idea what it means.
Fair enough. It comes down to embryonic development. So when the embryo of a deuterostome first begins to form and divide, the very first opening that develops in that little cell cluster becomes the anus.
Ooh, lovely.
Right, and the second opening becomes the mouth.
Okay.
Now, in the other major branch of complex animals, the protostomes, which includes things like insects, spiders, crabs, octopuses, snails, the mouth develops first.
Gotcha. So why does that matter?
Well, because sea urchins and humans are both deuterostomes.
Wait, what?
Yeah, it means that on the grand evolutionary tree, sea urchins sit on the exact same broad branch that eventually led to chordates, which includes all vertebrates like the eel and us.
Wait, seriously? We share a closer common ancestor with a spiny sea urchin than we do with a highly intelligent octopus.
Yes, we do. I mean, our lineages split hundreds of millions of years ago, obviously.
All right.
But fundamentally, you are more closely related to the sea urchin on your plate than the urchin is to the shrimp sitting right next to it.
That is absolutely mind-blowing.
It is. However, the urchin's evolutionary path took a radically different turn from ours. While the vertebrate lineage developed bilateral symmetry.
Bilateral meaning a left side and a right side.
Exactly, a left and right side, a front and a back, which is great for moving forward in a straight line. But sea urchins evolved radial symmetry as adults.
Meaning they are basically shaped like a wheel. There is no clear front or back.
Right, and they have a hard internal shell called a test, which is made of these interlocking calcium carbonate plates.
So they're kind of armored.
Very armored. And they don't have a centralized brain at all, just a nerve ring around their mouth.
So no brain, no front, no back.
Hmm.
Do they have eyes?
Not in the way we understand them, no. Though their entire body can detect light, and instead of swimming, they move using a water vascular system.
A water vascular system. How does that work?
They literally pump seawater through a complex internal plumbing system to extend and retract hundreds of tiny hydraulic tube feet.
That sounds like a machine.
Huh.
So if the eel is essentially a highly specialized biological submarine built for distance, the sea urchin is basically a living hydraulic mining drill.
That's a perfect analogy. And it's a drill that self-sharpens, by the way.
What do you mean self-sharpens?
Well, the structure they used to eat is an incredible piece of biological machinery called Aristotle's lantern.
Aristotle's lantern, that's a great name.
It really is. It's this complex arrangement of muscles and 5 calcium carbonate plates that act as teeth. And they use these to just scrape tough algae and kelp right off the rocks.
And the teeth sharpen themselves.
Yep.
As they scrape, the teeth continuously grow and self-sharpen. They are just built to grip, to endure, and to consume.
Wow. Okay, so we have these radically different evolutionary blueprints here. One is built for traversing thousands of miles of ocean and river, and the other is built for holding fast to rocks and basically chewing through forests.
Exactly.
And that blueprint dictates not only how they live, but the incredibly strange ways they reproduce. Because if you are listening to this and wondering why farming them is so complicated, well, it all comes down to how they're born.
Reproduction is the whole key to the farming problem.
Right. How do these completely different animals make more of themselves?
Well, let's look at the eel first. Because its life cycle is so mysterious that for thousands of years, human beings had absolutely no idea where eels came from.
Literally no clue.
None. The ancient Greeks, including Aristotle himself, were so baffled by the sudden appearance of baby eels in rivers that they literally thought they generated spontaneously from mud, or like from earthworms. I mean, if you've never seen an eel lay an egg, and suddenly millions of baby eels just wash up in the river mud every spring out of nowhere, spontaneous generation kind of makes logical sense for a philosopher in antiquity.
You can entirely forgive them for thinking that. Because the reality of the freshwater eel's life cycle is almost unbelievable.
Okay, lay it on me.
So eels like the Japanese eel, the European eel, and the American eel are what we call catadromous.
Catadromous. So that's the opposite of a salmon, right?
Exactly.
Because the salmon is an adromous, it's born in a freshwater stream, swims out to the ocean to get huge, and then swims back to the exact same freshwater stream to lay eggs and die.
Right, and a catadromous eel does the process in reverse. It grows up in freshwater rivers, lakes, and estuaries, and it can live there for years, sometimes decades, just getting bigger and storing fat.
Just hanging out in the mud.
Yeah. But when it is finally time to reproduce, it undergoes a radical physiological metamorphosis to prepare for a journey it will only make once.
Metamorphosis, like what changes?
Pretty much everything. Its color shifts from yellow or brown to a metallic silver, which helps it camouflage in the open ocean.
Okay.
Its pectoral fins get much larger. Its eyes literally double in size and change their visual pigment so the eel can see in the deep, dark blue of the ocean.
Its eyes double in size. That's intense.
It gets crazier.
Yeah.
Because most drastically, its digestive tract begins to atrophy and shut down entirely.
Wait, it stops eating.
It stops eating completely. It will digest its own stomach and intestines to squeeze out every last drop of energy for the trip.
Hold on, it digests its own stomach.
It really digests it.
That is insane.
Right. From the moment it leaves the river, it is basically a biological torpedo fueled entirely by stored fat, swimming thousands of kilometers into the open ocean.
Thousands of kilometers. Where do they go?
Well, for the Japanese eel, they migrate out to the western North Pacific near the Mariana Ridge. For the European and American eels, they swim all the way to the Sargasso Free, which is just floating out in the middle of the Atlantic Ocean.
How do they even know where to go? I mean, they've never been there before, right?
Nope, they've never been there as adults. It's completely instinctual.
That is wild. Or more importantly, how do we know they go there? Like, have we ever filmed eels spawning in the Sargasso Sea? No. We have never witnessed European or American eels spawning in the wild. Not once.
Wait, really? With all our submarines and cameras?
Never seen it. The ocean is just too vast and too deep.
Yeah.
We only know they spawn there because over the last century, marine biologists have dragged fine nets across the ocean, catching eel larvae.
Like crumbs.
Exactly. By mapping where the larvae get smaller and smaller and smaller, they finally pinpointed the geographic origin of the spawning grounds.
That is epic. It's like biological detective work.
It really was.
So they swim across an ocean basin, they finally reach this deep spawning ground, they reproduce, and then what? They swim back.
No. The adults exert so much energy. And remember, their bodies are so degraded by the journey and the fact that they haven't eaten in months.
Right, no stomach.
Right. They die after spawning. Wow.
Yeah. And then the eggs hatch deep in the ocean into these transparent, leaf-like larvae called leptocephaly.
Leptocephaly. I've actually seen pictures of these. They look absolutely nothing like an eel.
No, they don't.
They look like tiny translucent pieces of tape or like little willow leaves drifting in the water.
They are incredibly strange. They are totally flat, transparent, and their bodies are filled with a jelly-like substance rather than dense muscle.
I guess that helps them float.
Exactly, it helps them remain buoyant. They don't even have red blood cells at this stage. And these leptocephali just drift in the major oceanic currents, like the Kuroshio current for the Japanese eel or the Gulf Stream for the European eel.
For how long?
For months, sometimes over a year, just slowly making their way back toward the continental shelves.
So they're just entirely at the mercy of the current.
Completely. As they finally near the coast, they metamorphose again into glass eels, which are tiny, transparent, perfectly formed miniature eels.
Oh, so they finally look like eels.
Yes. And as they detect the freshwater output from rivers, they swim upstream into estuaries, gain some pigment, become what we call elvers, and then grow into yellow eels, which is that main adult growth stage in the river. And the cycle begins again.
It is a mythic journey. You have this animal crossing the globe, undergoing 3 or 4 complete physical transformations.
It's one of the great migrations on Earth.
But then you look at the sea urchin, and the spatial scale is entirely different. The sea urchin doesn't go anywhere.
No, an adult sea urchin is largely benthic, meaning it stays on the bottom. It might move a few meters to find better kelp, but it certainly isn't migrating across an ocean basin.
Right. So how do they reproduce if they don't travel to a spawning ground?
Because they don't migrate to a shared ground, sea urchins use a reproductive strategy called broadcast spawning.
Broadcast spawning.
Yeah, they simply release massive clouds of sperm and eggs directly into the water column, right exactly where they live on the reef.
So the parents never even interact. There's no mating ritual or anything. They just vent their genetics into the water and hope the currents mix them together.
Precisely. It's external fertilization. And from there, the fertilized eggs develop rapidly into embryos and then into free-swimming microscopic larvae called Pluteus larvae.
Pluteus.
Yeah. Now, remember how we said adult sea urchins have radial wheel-like symmetry?
Right, no front or back.
Well, the Pluteus larvae actually have bilateral symmetry.
Wait, really? The babies have a left and right side.
They do. They look a bit like microscopic translucent spaceships with long skeletal arms.
Why do they have arms if the adults don't?
The arms are covered in tiny hair-like cilia, and they use these to swim and to sweep microscopic algae into their mouths.
Oh, okay.
Yeah, and they drift in the plankton for weeks. If they survive being eaten by fish, if they find the right currents, and if they detect the right chemical cues from a rocky reef or a kelp forest below them, they drop out of the water column.
And then what?
They settle to the bottom and undergo a massive, rapid metamorphosis. They absorb their larval arms and transform into a tiny, radial, heavily armored juvenile urchin.
So both of these animals are essentially doing the exact same thing philosophically. It's a quantity over quality parenting strategy.
Very much so.
There is absolutely zero parental care. You just release millions of offspring into the void. The ocean acts as this violent, chaotic nursery, and you just hope 1 or 2 survive to adulthood.
That is exactly it.
But the mechanics are opposites. The eel travels across the globe to reproduce in one concentrated spot in the open ocean. The sea urchin stays glued to its rock and reproduces locally.
Right.
But doesn't that immobility create its own massive problem? I mean, if I just release sperm into the ocean, isn't it just going to wash away before it ever finds an egg?
You've hit on a really critical ecological concept here called the alley effect.
The alley effect.
Yeah. Because sea urchins broadcast spawn into the open water, their reproductive success depends entirely on population density.
Because they need to be close to each other.
Exactly. If sea urchins are too spread out, say, only 1 urchin every 10 square meters, the sperm and eggs will simply dilute in the ocean currents and never meet.
Oh, that makes sense.
They need a high density of neighbors, and they also need environmental cues, like a specific water temperature change or a phytoplankton bloom, to trigger them all to spawn at the exact same time.
So while the eel requires an open corridor of thousands of miles of ocean, the urchin requires a really tightly packed neighborhood.
Right.
But when we look at both of these cycles, it really strips away the romance, doesn't it?
What do you mean?
Well, we marvel at this epic journey, but really, this means their reproduction is entirely at the mercy of the wild ocean. Like if climate change shifts the Gulf Stream even a little bit, or if warming waters change the timing of the plankton blooms, an entire generation of eels could just vanish into the Atlantic.
Yes, that is a huge concern.
Or an entire generation of sea urchins could fail to settle on the reef.
That is the core vulnerability of both species. They don't just live in the ocean. They are biologically tethered to the physical and chemical dynamics of the sea. They completely rely on the ocean's physical movements to act as the conveyor belt for their young.
And because these reproductive cycles are so deeply entangled with the wild, untamable ocean, humanity had to invent highly specific, ingenious ways to capture them.
We did.
Because long before we ever dreamed of trying to farm them in tanks, we had to hunt them. So how did early humans actually catch these animals reliably if their lives are so chaotic? Because humans have been eating eel and uni for thousands of years, right?
Thousands of years. And early on, catching them required a profound, intimate relationship with a specific place. You couldn't just cast a net randomly and hope for the best.
You had to know what you were doing.
Exactly. If you look at the archaeological record, you see incredible human ingenuity built on deep observation. One of the most striking examples is the Budge Bim cultural landscape in southeastern Australia.
Budge Bim. What were they doing there?
The Gunditjmara people engineered one of the oldest and most extensive aquaculture systems in the world there, and it has been carbon dated to roughly 6,600 years ago.
Wow, that is ancient.
It is. And this wasn't just walking down to the river with a spear. This landscape is shaped by ancient basalt lava flows. And the Gunditjmara used that volcanic rock to engineer a massive interconnected system of channels, weirs, and dams.
To catch eels.
Yeah, to trap, store, and manage the short-finned eel, which they call kuyang.
So they weren't just foraging, they were actively doing landscape-level wetland management.
They were basically terraforming. They built stone funnels that would direct the migrating eels into long woven baskets. They knew exactly when the seasonal rains would flood the wetlands, how the water would flow through the basalt, and exactly when the eels would move downstream.
That is brilliant.
And they didn't just catch them. They trapped the eels, they held them in holding ponds to keep them fresh, and they harvested them systematically. They often smoked them in hollow trees for long-term preservation.
That implies a deep ecological literacy. I mean, they didn't just understand the fish. They understood the entire hydrology of the watershed.
It was sustainable observational engineering, and you see a very similar depth of knowledge with early sea urchin harvesting, too.
Really? Where?
Well, coastal shell middens all over the world,
Mm.
in Japan, in the Mediterranean, in the Pacific Northwest of the Americas, they show that human beings have been consuming sea urchins for over 5,000 years.
But gathering sea urchins back then couldn't have been easy. It's not like picking an apple off a tree. You have to navigate the surf zone, you have to hold your breath, and deal with freezing water.
And beyond the physical difficulty, you had to possess intense seasonal knowledge. You had to know the tides, the moon phases, and the water temperature.
Because the uni changes throughout the year, right?
Exactly. You had to know which specific season meant the urchin's gonads would be swollen, rich, and sweet, and when they would have already spawned, leaving the shell empty and bitter.
So it required a real sensory relationship with the tide pool.
Absolutely. It was entirely limited by the capacity of the human body. You had your eyesight, your hands, your breath-holding ability, and maybe the limits of a small canoe.
Right.
And because of those physical constraints, you generally couldn't take more than the local ecosystem could replenish.
But then the industrial shift happened. The great acceleration of how we pull things from the sea.
Right. We introduced the steam-powered trawler around the turn of the 20th century. Suddenly, fishing boats didn't depend on the wind or human muscle anymore.
You could just keep going.
Yeah, they could drag massive nets across the seafloor. Then came refrigeration, freezing, canning, sonar to see underwater, and global shipping logistics.
So the fishing village knew the fish as a season, but the supermarket knows it as inventory.
That is the defining shift right there. Industrialization completely abstracted our relationship with the ocean. We stopped asking, what can this specific reef sustainably give us today? And we started asking, how much product can the global market absorb this quarter?
Yeah, that's a huge difference in mindset.
Because sonar meant fish couldn't hide in the depths anymore. Refrigeration and air freight meant a sea urchin pulled from a freezing kelp forest in Oregon could be served at a sushi bar in Tokyo 48 hours later. It fundamentally separated the eater from the ecosystem.
And if we connect this to the bigger picture, this technological acceleration is exactly what created the seafood supply crisis we face today. Because wild capture cannot expand infinitely.
No, that cannot.
There is a hard biological limit to how much you can extract from the ocean before the populations just collapse. We hit peak fish decades ago.
We did.
The sources mention that in 2022, global fisheries and aquaculture produced a record 223 million tons of aquatic animals. And to meet that relentless scaling demand when the wild ocean couldn't provide any more, we had to pivot. We were forced to try and domesticate the ocean itself. We had to invent aquaculture.
And that transition is where the story of these two animals becomes incredibly fraught. Because according to the UN's Food and Agriculture Organization, the FAO, the year 2022 marked a massive milestone.
What was the milestone?
Aquaculture officially surpassed wild capture.
Wow.
Yeah, farms produced 94.4 million tons of aquatic animals, which is 51% of the global total. So for the first time in human history, we are officially farming more seafood than we are hunting.
But wait, I want to challenge that word.
Farming.
Yeah, farming. Because when we hear farming, we picture terrestrial agriculture, right? We picture a field of wheat or a herd of cattle. We picture control. But farming underwater has to be fundamentally different, right?
It is drastically different, and you're right, we have to be very careful using the word farming when it comes to the ocean.
Because we don't have that same control.
Exactly. With terrestrial agriculture, we have mastered biological control over millennia. We control the genetics of the seed, the chemistry of the soil, the irrigation, the fertilizer, the sunlight, and the harvest cycle.
We built a closed, predictable loop.
Yes. But aquaculture is not simply farming underwater. You are dealing with a three-dimensional fluid environment. You have to manage complex dissolved oxygen chemistry, rapid disease transmission through the water column, the accumulation of dissolved waste, and most importantly, reproductive mysteries that we still have not solved.
And this is exactly where eel farming becomes so controversial, isn't it?
Oh, absolutely.
Because I think a lot of people see farm-raised eel on a sushi menu or at the grocery store and think, oh, great, it's sustainable. They bred it in captivity, so they aren't hurting wild populations.
That's what the label implies.
But eel farming is a myth, isn't it? It's what the scientific community calls capture-based aquaculture.
That is correct. Despite decades of intense scientific research and millions of dollars in funding, we have not been able to commercially close the life cycle of the freshwater eel.
Okay, what do you mean by close the life cycle?
It means we cannot put a male and a female adult eel in a tank, have them spawn, hatch the eggs, and efficiently raise the larvae into adults at an industrial scale.
We just can't do it.
We can do it with salmon. We can do it with tilapia. We cannot do it with eels. While the larvae, those delicate, transparent, leaf-like leptocephali we talked about earlier, they have incredibly specific, bizarre oceanic diets in the wild. They feed on marine snow.
Marine snow. What is that?
It is essentially microscopic organic debris floating in the deep ocean. It is almost impossible to replicate that diet affordably in a lab.
Oh, wow.
Furthermore, the adults require the immense pressure of the deep ocean to trigger their final sexual maturation. So how do eel farms operate?
Yeah, how do they?
They rely entirely on the wild ocean to do the breeding for them.
Hold on. If you're just waiting for wild animals to breed in the ocean and then catching them, how is that legally called farming? That sounds like you're just delaying the hunt.
It is a delayed hunt, heavily subsidized by industrial feed. The farms wait for the wild eels to migrate, spawn in the Pacific or the Sargasso, and then when those millions of tiny transparent glass eels swim back toward the continental coast to enter the freshwater rivers, the industry catches them.
They just net the babies.
They scoop up the wild babies by the millions using fine mesh nets in river mouths.
So they capture the wild babies, transport them to massive indoor recirculating tanks or outdoor ponds, and just feed them high-protein fish meal to quickly grow them to market size.
Exactly. The farm is entirely dependent on wild recruitment. If the wild population of glass eels collapses, the farming industry collapses with it instantly.
That's terrifying.
You aren't domesticating the animal at all. You are just outsourcing its adolescent growth phase to a temperature-controlled tank.
Here's where it gets really interesting, to use an analogy. Eel farming is like trying to finish a marathon someone else started.
I love that analogy.
Right. You let the wild ocean run the first 20 miles, the hardest part of the race, the spawning and the larval drift, and then you grab the runner right before the finish line, put them on a treadmill in a warehouse, and claim you ran the whole race yourself.
That is a highly accurate way to look at it. You are capturing the end result of a wild biological miracle and monetizing it. And the dynamic with sea urchin farming, or what is more accurately called uni-ranting, is entirely different but equally strange in its mechanics.
Right, because with uni, the bottleneck isn't the life cycle. We actually can breed sea urchins in captivity pretty easily, right?
We can, yes.
The problem is the quality of the product, and specifically a phenomenon called zombie urchins. Explain this to me, because it sounds like a literal horror movie.
It essentially is an ecological horror movie. In certain marine ecosystems, particularly along the Pacific coast of North America, the natural predators of the purple sea urchin have been drastically reduced.
Okay, what eats sea urchins normally?
Historically, sea otters and sunflower sea stars kept urchin populations in check. Sea otters would dive down, grab an urchin, bring it to the surface, and literally smash it open on their chests with a rock.
Oh, right, they're famous for doing that.
Yeah. But the fur trade in the 1800s nearly wiped out the otters, and more recently, a massive wasting disease wiped out the sunflower sea stars.
So you remove the predators, and the urchin population just explodes.
They explode, and they are voracious grazers. An army of sea urchins will march across the seafloor and eat through entire kelp forests.
Just clear-cutting the forest.
They literally chew right through the holdfasts. Those are the root-like structures that anchor the massive kelp stalks to the rocks. Once the holdfast is chewed through, the kelp just washes away in the tide. And when the forest is gone, you are left with an urchin barren.
An urchin barren, meaning just a completely stripped, rocky, underwater desert paved with millions of spiny urchins.
Exactly, just a moonscape of spikes. But here is the bizarre biological quirk of the sea urchin. When they run out of food, they don't just starve to death and die off, which would naturally allow the kelp to recover.
Oh, they don't?
No, they enter a state of semi-dormancy. They can survive for years, sometimes decades, in a state of starvation. They become zombie urchins.
Decades without food.
Yeah. They are biologically alive, but they are hollow inside. To conserve energy, they completely downregulate their metabolism and literally reabsorb their own gonads. The uni shrinks to virtually nothing.
So from a commercial fishing standpoint, these millions of urchins carpeting the seafloor are completely worthless. You can't sell an empty shell to a sushi chef.
Right. And you can't just harvest them and crack them open because there's no meat inside.
So what does the aquaculture industry do?
They look at these worthless, starving urchins destroying the ecosystem, and they engineer a solution. Companies send commercial divers down to harvest these zombie urchins by the thousands from the barrens. They bring them up to shore-based aquaculture raceways or tanks, and they ranch them.
How does that work? How do you bring a zombie back to life?
By feeding them an incredibly rich diet. They feed these starving urchins highly formulated algae-based pellets. Because the urchin's biology is incredibly efficient at converting food into reproductive tissue, it only takes about 8 to 9 weeks.
Just 2 months.
In 2 months, a hollow, starving, ecologically destructive urchin plumps up and transforms into a premium, bright yellow, sushi-grade uni product.
Okay, to use another analogy. If eel farming is finishing a marathon someone else started, uni farming is like taking a starving artist off the street, putting them in a luxury penthouse, and force-feeding them caviar and truffles for 2 months until they produce a masterpiece.
That's exactly what it is.
You are taking an animal from a heavily damaged ecosystem and intensely managing its biology just to improve one specific organ.
Yes, the entire process is hyper-focused on the gonad. You aren't trying to grow the animal shell larger, and you aren't trying to breed them. You are simply manipulating their feed to make them biologically rich again in the shortest amount of time possible.
So you have these wild babies raised in massive indoor tanks on one side, and these hollowed-out zombies pumped full of nutrients on the other. How does that engineered trauma translate to the kitchen?
It translates in completely opposite ways.
Right, because these stark differences in biology and the drastically different ways humans attempt to farm them dictate exactly how these two animals must be treated once they finally reach the plate. We're looking at heat versus cold, transformation versus restraint.
Exactly.
Because the culinary traditions around these animals couldn't be more opposed. Let's start with the eel.
Sure. Eel flesh is physically very unique. It is dense, rich, incredibly fatty, and very high in protein. But it has a critical biological defense mechanism that has defined how humans eat it for centuries.
And what's that?
Eel blood contains toxic proteins.
Wait, what happens if I drink eel blood or eat raw eel?
It contains an ichthyotoxin. If it gets into your system, it can cause severe systemic reactions. We're talking muscle cramping, spasms, vomiting, and if it enters the bloodstream directly, it can attack red blood cells and affect the heart.
Wow, so it is actually dangerous.
It is dangerous.
Yeah.
However, the saving grace is that these toxins are proteins, which means they are completely neutralized by heat. The heat denatures or unravels the toxic proteins, making them perfectly safe to eat.
So that's why across almost every culture on Earth, eel is intensely cooked.
Right, you never see eel sashimi. It is always subjected to intense culinary transformation.
Take Japan, for example, where you have unagi no kabayaki. This isn't just cooking, it is an absolute art form built around fire.
It is a masterclass in technique.
You split the eel down the back, carefully debone it, skewer it on bamboo, and grill it over intensely hot charcoal. And in some regional styles, like the Edo style in Tokyo, they actually steam it halfway through.
Right, to melt the fat and make it incredibly tender.
Yeah, and then they repeatedly dip it in tear, which is this sweet, thick reduction of soy sauce, mirin, sake, and sugar, and grill it again until the sugars caramelize and it becomes beautifully lacquered.
And the incredibly high fat content of the eel is exactly what allows it to survive that intense culinary punishment. If you tried to grill a lean fish like cod that way, it would dry out, flake apart, and completely disintegrate into the coals.
Yeah, it would be ruined.
But eel absorbs the smoke, renders its fat, and turns into something deeply savory, rich, and luxurious. And you see this exact same reliance on heat transformation in European traditions as well.
Right, smoked eel.
Yes. In Northern Europe, places like the Netherlands, Denmark, and Northern Germany, smoked eel is a profound delicacy.
Oh, I've seen that in markets there.
Yeah, the dense flesh and heavy oil carry wood smoke perfectly. The smoking process cooks the meat, neutralizes the toxins, extends its shelf life significantly, and concentrates its rich flavor.
And we also have to mention the historical working class survival foods, like the jellied eels of London's East End.
Yes, jellied eels.
This is fascinating to me. In the Victorian era, the River Thames was heavily polluted from the Industrial Revolution. But the European eel is incredibly resilient.
Huh?
They could survive in water where other fish just suffocated, so they became a cheap, hyper-abundant source of protein for poor urban workers.
Exactly. And the preparation was born of pure utility. They would chop the eel into rounds, boil it in a spiced stock with nutmeg and lemon juice, and let it cool.
And it turns into jelly.
Because the eel is so rich in natural collagen, as the broth cooled, it would naturally set into a firm, clear jelly. It was basically 19th century fast food.
Oh, wow.
It preserved the meat for a few extra days without needing a refrigerator, keeping the bacteria out by encasing the meat in gelatin.
So every single one of those traditions, kabayaki, smoking, boiling into jelly, uses heat and aggressive technique to conquer the eel, to neutralize its defenses, and to preserve it against time.
Yes.
But then you look at uni, and the culinary philosophy is completely inverted. You don't conquer uni, you surrender to it. It is all about immediacy and extreme fragility.
That is because you aren't eating muscle tissue, remember? You are eating a highly active reproductive organ.
Right.
The flavor profile of pristine, perfect uni is astonishing. It should be sweet, briny, creamy, slightly custard-like, with a faint, clean minerality. It should literally taste exactly like a perfect breath of cold ocean air.
That sounds amazing.
But the moment you crack open the Urchin's test and expose that gonad to the air, a biological clock starts ticking very loudly.
Why does it decay so fast?
Because it is packed with enzymes. Once the animal dies, those enzymes immediately start a process called autolysis.
Autolysis. What's that?
Essentially, the organ begins breaking down its own tissues. If it isn't kept meticulously cold, or if it is jostled or mishandled, it physically collapses. It turns mushy, watery, bitter, and develops a sharp, metallic, highly unpleasant, ammoniated taste.
Ugh, that sounds awful.
It is. Furthermore, because uni is almost always eaten raw, there is a very real health risk if the cold chain breaks for even a few hours. Harmful bacteria, particularly Vibrio parahemolyticus,
Vibrio.
yeah, that naturally occurs in marine environments and can multiply rapidly in raw seafood at room temperature. It leads to severe food poisoning.
So the culinary preparations are built around doing absolutely as little to it as possible. You have Indian nigiri in Cheyenne, just a delicate bright orange lobe of urchin resting on perfectly seasoned sushi rice, often wrapped in a thin band of nori seaweed, just to hold its soft, melting shape.
Perfection and simplicity.
Exactly. Or in the Mediterranean, in places like Sicily or Sardinia, you have spaghetti irici. You boil the pasta, take it entirely off the heat, and gently toss it with raw sea urchin, olive oil, lemon, and maybe a little garlic.
Right. The residual ambient heat of the pasta gently warms the uni, melting it into this rich, creamy sauce without actually cooking it.
It is the absolute definition of culinary restraint. Eel preserves beautifully. It becomes food through human patience, fire, smoke, and time. Uni cannot be preserved easily.
Some companies try freezing it or treating it with alum, a chemical astringent, to help the lobes hold their shape during shipping. But purists will immediately tell you that alum alters the texture and leaves a slightly bitter aftertaste.
So uni is really the taste of a specific, fleeting moment. Eel survives our technique, but uni survives only through our delicate care.
Exactly.
Think about it. If you're listening to this, when you eat eel, you are tasting fire, smoke, and human patience. You're tasting a process. When you eat uni, you are racing against the clock to taste the ocean before it spoils.
It's a completely different philosophy of eating.
But the irony here is that the luxury we experience at the sushi, counter the pristine plating, the quiet reverence, the perfect rice, it totally obscures the massive, chaotic, and often dark reality of how these animals are actually sourced.
It completely hides the supply chain.
Right. We put so much care into the cooking or the plating, but we ignore the absolute chaos behind it. Which brings us to the hidden price. Let's look at the economics, the ecology, and the deeply tangled moral knot behind these two foods.
It gets really complicated here.
Let's start with the dark side of the eel trade. We mentioned earlier that eel farms need millions of wild glass eels to stock their tanks, but because the European eel is critically endangered, the European Union strictly regulates its trade and completely bans its export outside of the EU. So what happens when intense East Asian aquaculture demand meets a strict European export ban?
You get the rise of the eel mafia.
The eel mafia.
Yeah. When you criminalize a highly desired commodity, the black market steps in. The illegal trafficking of European glass eels has become one of Europe's largest, most lucrative, and most damaging wildlife crimes.
Bigger than, like, ivory.
The numbers are staggering. Europol reporting suggests that this illegal trade is worth up to 3 billion euros annually during peak years.
Wait, 3 billion euros?
Ah.
For baby fish that look like transparent noodles.
Yes.
How does a baby fish become Europe's biggest wildlife crime?
Ah.
How does that even work practically?
Because per kilogram, glass eels are one of the most valuable wildlife commodities on Earth. They sometimes fetch more than ivory or cocaine on the black market.
That is just insane.
Organized criminal networks recruit local poachers to illegally net these glass eels as they enter river mouths in France, Spain, and the UK in the dead of winter. The poachers work at night using fine mesh nets and sell the catch to middlemen.
And then what? How do they get them out of Europe?
The eels are held in secret basement tanks, carefully packed into special plastic bags filled with water and pure oxygen, surrounded by ice packs to lower their metabolism, and hidden inside ordinary hard-shell passenger suitcases.
Wait, so there are literally people flying commercial airlines with suitcases full of millions of baby eels?
Exactly. The couriers fly out of European airports, often taking circuitous routes to avoid detection, and land in places like Hong Kong.
Oh, wow.
Once they arrive, the eels are laundered into the legal aquaculture system. They are driven to massive farms in mainland China, put into the tanks, grown to adulthood, slaughtered, processed, frozen, and exported globally as generic unagi.
So a consumer could be sitting in a nice restaurant in North America, ordering an unagi roll, thinking they're making a fine, safe choice because the menu says farm-raised, and they're actually eating a critically endangered species that was poached in France and smuggled in a suitcase by an organized crime syndicate.
That is exactly the reality of opaque global supply chains. Once the eel is processed and lacquered in sauce, its origin is virtually untraceable to the naked eye.
It's just unagi at that point.
Right. And the ethical dilemma with eel is profound. Should we continue to eat an endangered animal that we cannot sustainably reproduce?
That's a huge question.
Does cultural and culinary tradition, like the Japanese summer custom of eating unagi to gain stamina for the hot weather, does that justify driving a wild population toward extinction? And fundamentally, can we even call eel farmed if the entire industry relies on poaching wild babies from rivers?
It's a really heavy moral weight. If I buy farm-raised eel, I might actually be funding a cartel. But then you look at uni, and the ethical dilemma is completely flipped on its head. It's the urchin-barren paradox.
Right. With the European eel, the crisis is extreme scarcity. With the purple sea urchin off the coast of California and Oregon, the crisis is extreme overabundance.
Too many of them.
Yes. As we discussed, without predators like sea otters, urchins boom and turn vibrant, highly biodiverse kelp forests into dead zones. Kelp forests are essentially the rainforests of the ocean.
Right.
They capture massive amounts of carbon, they buffer wave energy against the coastline, and they provide critical nursery habitat for hundreds of species of fish and invertebrates. When urchins destroy the kelp, the entire local ecosystem collapses.
So it's an environmental disaster. And environmental groups and even government agencies like NOAA are actually funding projects to go down and smash or remove millions of these urchins just to save the kelp.
Yes. They are treating the urchin not as a resource, but as an ecological pest that needs to be culled. Divers go down with hammers and literally smash the urchins on the rocks to clear the area so kelp can regrow.
That's intense.
And this creates an incredibly strange ethical inversion. Suddenly, commercial harvesting of an animal, taking it out of the ocean to eat it, is being framed as a vital act of ecosystem restoration.
Right.
The aquaculture firms that harvest these hollow zombie urchins and ranch them in tanks for uni are marketing their product as restorative seafood.
So by eating this uni, the argument goes, I am personally helping to save the kelp forest.
That is the pitch. But this raises an important question. Does a farm actually protect the ocean if it relies on poaching wild babies like the eel? And conversely, for invertebrates like urchins, how much animal welfare concern do we owe them?
That's a really good point.
We're taking these urchins from the reef, holding them in artificial tanks, manipulating their diet, and cracking them open. They don't have a centralized brain, sure, but they have complex nervous systems, and they respond to stimuli and stress.
So do we just entirely disregard their welfare because we've labeled them as destructive pests?
It's a tough question.
And beyond welfare, there is a deeper philosophical question here about commodifying restoration. If we turn kelp restoration into a highly profitable luxury market for premium uni, are we really healing the ocean? Or are we just finding a new way to profit from an imbalance that human beings caused in the first place?
Oh, absolutely.
If an aquaculture company builds its entire business model and profit margins on the existence of urchin barrens, do they actually want the barrens to disappear? Or do they now have a financial incentive for the ecosystem to remain permanently degraded so they have a steady supply of zombie urchins?
It creates a perverse incentive. You are solving a problem by creating an industry that depends on the problem never truly being solved.
So what does this all mean? We are looking at one animal we are eating into extinction and another animal we are eating to supposedly save a forest. And the human toll is deeply hidden in both of them.
Very deeply hidden.
Because both of these industries, at their core, rely on hidden, dangerous physical labor.
Absolutely. The eel trade relies on secretive, dangerous netting in freezing rivers in the middle of the night, often by marginalized people looking for a payout from the syndicates. The urchin trade relies on commercial diving, which is inherently dangerous work.
Yeah, that's not an easy job.
Not at all. Divers face ripping currents, unpredictable weather, equipment failure, and immense physical strain on their bodies. And yet, the massive profit margins of the global luxury market, the prices paid at the high-end sushi counter rarely trickle down to the person holding the net in the dark or wearing the heavy dive suit in the freezing kelp bed.
The farther the eater is from the coast, the easier it becomes to forget the worker. When we step back from the biology, the taxonomy, the economics, and the cooking, these two animals stop being just seafood. They become powerful, living mirrors for humanity's relationship with the natural world.
They really do.
Which leads us to look at what these animals mean to us on a deeper cultural level.
Throughout human history, the eel has always been a potent symbol of mystery, of hidden origins, of stamina, and of transformation. Because of its incredible migration, because of its ability to cross from the saltwater ocean to the freshwater river, it represents the food of the long journey.
It's a survivor.
Yeah. In Polynesian mythology, the eel is deeply tied to origin stories, to the creation of life and the nature of death. In Japan, as we noted, it represents endurance, a food rich enough to sustain you through the grueling, exhausting heat of summer.
And uni. Uni represents sensuality, fertility, immediacy, and absolute fragility. It is the food of the exact moment. It represents our desire to capture the very essence of the ocean before it spoils and slips away.
If we look back, civilization itself began in attention. Those indigenous Gundutjmara people at Bujbim 6,600 years ago, engineering the basalt flows, or the ancient coastal foragers leaving urchin shells in middens, they were watching the tides, monitoring the migrations, and harvesting in a state of deliberate balance.
Right.
Their physical survival depended entirely on knowing the limits of their local ecosystem.
But civilization scaled into abstraction. The larger our cities grew, the further our supply chains stretched across the globe, the easier it became to forget where food actually comes from. We replaced deep ecological attention with mechanical industrial extraction.
And we replaced balance with inventory. We demand unagi year-round, regardless of the migration. We demand premium uni, regardless of the season or the health of the kelp forest. And the wild ocean is simply breaking under the weight of that abstraction.
Let's reflect on the nature of abundance for a second, because I think that's what this entire deep dive really exposes. A kelp forest full of millions of starving zombie urchins isn't abundance.
No, it's not.
It's the illusion of life masking an ecological collapse. And a supermarket freezer full of neatly packaged farmed eel isn't abundance if the rivers are empty and the wild population is teetering on the edge of extinction. We've confused inventory with health. We think that because we can buy it easily, the ocean must be doing fine.
That is the ultimate danger of the modern globalized food system. It presents us with endless choice and perfect presentation while completely hiding the endless ecological cost.
Let's synthesize everything we've uncovered today. We've taken a massive deep dive through the evolutionary tree, seeing how the eel and the urchin split hundreds of millions of years ago into two entirely different ways of being alive.
Two radically different blueprints.
We've traveled across the migrating currents of the Pacific Ocean with the leptocephaly, into the murky tanks of modern capture-based aquaculture, through the illegal midnight smuggling routes of Europe, and right down to the pristine, quiet surface of the sushi counter.
And we've seen how both animals hide their reality. The eel hides its reality in complex, globe-spanning migration and a murky, often illegal capture-based trade.
Yeah.
The uni hides its reality behind sharp spines, devastated ocean barrens, and the delicate, frantic human labor required to maintain the cold chain.
So the next time you sit down to eat seafood, whether it's at a luxury tasting menu or just a casual neighborhood spot, look past the plate. Try to see the entire chain of events that brought that animal to you.
It's so important to do that.
Ask yourself, who caught this? Was it a diver braving the surf or a poacher working in the dark? Who profited from this? And what living, breathing ecosystem had to be permanently altered or managed or depleted so this exact bite could arrive here?
Understanding those questions doesn't mean you can never enjoy seafood again, but it demands that you eat with respect, with awareness, and with a steadfast refusal to be willfully blind to the cost of your appetite.
Food for thought before we go. We've seen how human beings are attempting to aggressively manage the ocean. We are ranching starving urchins in tanks to try and save the kelp forests. And we are piping wild baby eels into massive recirculating aquaculture facilities to feed our culinary traditions.
We are trying to engineer it all.
Right. So if this trend of intense technological management continues, are we slowly converting the entire wild ocean into a globally managed fenced-in garden? And if we do finally succeed in engineering the ocean to perfectly suit our appetites, what happens to the wild creatures that simply refuse to be domesticated?